Okay. So there is a relation between the torque and the moment of inertia. Relation between the torque and the moment of inertia. Torque on the body or net torque on the body is equal to the moment of inertia of the body multiplied by the angular acceleration of the body. But here now, what you have to remember, you have to take uh, in consideration the axis, means about which axis you are calculating the torque. So, for example, this formula we derived, na? Torque is equal to a moment of inertia. Torque is equal to moment of inertia into the angular acceleration. Okay, so angular acceleration of this suppose this body is rotating. Okay, I'm drawing here. Suppose this is the body. This is any random rigid body, and this rigid body is rotating about this axis. This rigid body is rotating about this axis, and this is rotating anti-clockwise and having the angular acceleration alpha. And I told you that each and every particle of this body will have the same angular acceleration. Okay. Now this relation torque on the body is equal to moment of inertia of the body into alpha of the body. So net torque on the body about this axis is equal to moment of inertia about this axis is equal to the angular acceleration about this axis. So axis you have to, okay, I can say that there can be infinite number of axes that can pass through this body. If I am saying suppose this is the axis. So if you are writing this expression for this axis, then for this expression will change. About this axis, the moment of inertia will change. Okay, alpha will change. So remember this point. So now we will do some of the questions on this concept. Torque is equal to I alpha. You can compare it with force is equal to mass into acceleration. In rotational motion, instead of force, there is a torque. Instead of mass, there is a moment of inertia. Instead of acceleration, there is an angular acceleration. Okay. First question. Okay. First question. See this question. In this question, this is a one-dimensional rod and a force is acting at a distance of L by 4 from this axis. This is a axis, okay? This is the axis, and a force is acting like this. Means at this point, this rod is pivoted. This is a pivoted point. What is the meaning of the pivoted? If this is a pen or this is a body, this is a linear rod, you can say the linear rod. So if pivoted means about this point, this will be rotated. Okay, pivoted means about this is pivoted means if you will apply a force, this body or this rod will rotate about this axis, okay, here up axis, this axis the body will rotate. So here this is the pivoted point and a force is acting at a distance of L by 4. L is the length of the rod, M is the mass of the rod. Total length of the rod is L, and they are asking they're asking the angular acceleration and the angular displacement in t seconds. Angular acceleration and angular displacement in t seconds. What is the angular acceleration? Angular acceleration is alpha. Angular acceleration is alpha and angular displacement is theta. So we want to find alpha and we want to find theta. Okay, so see how we will find. First, calculate the torque on this body. Calculate the torque on this body about this axis. About this axis, the torque will be I alpha. Oh, sorry. I alpha will be also there, but first torque can be force into this distance, R into F. R into F will be the torque. So R is L by 4. R is the perpendicular distance from the axis of rotation. So this will be the perpendicular distance and this will be the force multiplied by F. Okay. So torque on the body is L by 4 into F. Now torque about this axis, I told you there is one more formula to calculate the torque about this axis, I into alpha. I means moment of inertia about this axis and angular acceleration. So moment of inertia about this axis is ml square by 12. Okay, about the axis perpendicular to the plane of this rod, passing to the center. This will be the center of mass. Okay, this rod is pivoted at the center of mass. So about this axis, the moment of inertia is ml square by 12. So you will write moment of inertia I into alpha is equal to L by 4 into F. So moment of inertia is ml square by 12 and into alpha is equal to L by 4 into F. So from here L and L will be cancel out. So alpha you can find from here. So alpha will be, it will 4 3s are 12. So it will become 3F by M, I think. 3F by 3F divided by ml. So this is the angular acceleration of this rod, okay, about this axis. Now initially this rod will be in rest. Initially this rod will be in rest when you are applying the force. This, suppose this is a rod, okay, and initially this rod is in the rest, and when you will apply the force, then it will rotate. Now when you will apply the force like this, then it will rotate, okay, and swept some angle, you can say. So after applying the force, okay, there will be some angular displacement of this rod. Okay, so that angular displacement you can calculate. Now see this alpha, 3F by ml. This alpha is constant, force is constant, mass of the rod is constant, length of the rod will remain constant. So this whole alpha is constant. This is constant, okay. If this alpha is constant, so we can apply the equations of the motion. So for calculating the angular displacement, we have the equations of the motion. You can see here, 3 equations of motion. So angular displacement we will get from these 2 equations. Okay. So I am not applying this equation because I do not have the final angular velocity, but I can apply this equation of motion. Okay. So I will apply this equation of motion. So what is the second equation of motion for the rotational motion? Angular displacement theta is equal to omega t plus half alpha into t square. You can compare this with this. S is equal to ut plus half at square. Now omega here is the initial angular velocity, and initially this will be at rest. So you will put here 0. So angular displacement theta is equal to 0 into t plus half alpha. You have alpha 3F by ml. So it will be 3F divided by ml into t square. So the angular displacement of the rod will be theta is equal to 3 by 2. You can write 3F t square, 3F t square divided by 2 ml. So this is the angular displacement. This is the angular displacement of this rod. Understood? Divyangi and Hiba?
Yes, sir.
Yes, sir.
Okay. Right on. Scroll down.
Yes, sir.
Completed, Hiba?
Yes, sir.
Okay. Next question. So see this question. In this question, they are saying a wheel with moment of inertia. MI means moment of inertia 2 kg meter square rotating at 50 RPM. RPM means rotation per minute. Means in 1 minute there are 50 rotation. Okay. Is brought to rest. Brought to rest. Suppose the wheel is rotating like this and finally the wheel is at rest somehow. They're asking find the torque required to bring it to rest in 1 minute. Means in 1 minute, if we want to stop that wheel, how much torque we have to apply? How much torque we have to apply? Okay. So see this question now. What is given? Moment of inertia is given. This is a wheel, suppose. This is a wheel. This is a wheel. Okay. And this wheel is rotating about this axis. Wheel rotates about the center of mass. Okay. This is rotating about the center of mass. About this axis. This wheel is rotating. Moment of inertia of this wheel is given as 2 kg meter square. So see what data is given to you. 2 kg meter square. Kg meter square is the unit of moment of inertia. Rotating at 50 rotation per minute. This wheel is rotating 50 rotation per minute. There is one term that is known as the frequency. That is known as the frequency. There is a relation between the frequency and the angular velocity. Okay. So angular velocity. First, we will calculate the angular velocity of this wheel. Okay. So angular velocity and the frequency is given by 2 pi into f. Now this value is given 50 rotation per minute. So frequency is number of rotation in 1 minute, in 1 second. In 1 second, the number of rotations will be the frequency of this wheel. So they are saying that 50 rotation in 1 minute. So in 1 minute, how many rotations are there? 50 rotations. 50 rotations. 1 minute 50 rotation means you can say in 60 seconds there will be 50 rotations. Now in 1 second you can say 50 divided by 60 rotations. Now frequency is number of rotation in 1 second. In 1 second, the number of rotation will be frequency. So frequency, linear frequency of this wheel will be 50 divided by 60 and the unit of frequency is hertz. Now you can find omega. What will be the angular velocity with which the wheel is rotating? Omega is equal to 2 pi into frequency. So it will be 2 pi and frequency will be 5 by 6. 5 by 6 because this is the 0 and 0 will be cancelled out. So you will get 2 3s are 6. So it will become 5 pi divided by 3 radian per second. So now with the help of this, you have find out the angular velocity. Okay. Indirectly, they have given the number of rotation per minute. For that, with the help of this, we can find the frequency, and with the help of the frequency, we can find the angular velocity. Now we have the angular velocity of this wheel. Initial angular velocity means the, and after that they are saying find the torque required to bring it to the rest in 1 minute. Okay, if this is coming to the rest in 1 minute, means they are saying if the initially the wheel is rotating at 5 pi by 3 radian per second, finally the wheel is at rest. And in how many seconds? In 1 minute, or you can say in 60 seconds. Okay, in 60 seconds, finally it will be at rest, and they are asking what will be the torque during this, means how much torque you will apply to get it in the rest. So now how we will calculate first angular acceleration? We can find the angular acceleration of this. So angular acceleration can be find out with torque is equal to I into alpha. Okay, torque is equal to I into alpha, and we can apply the equation of the motion here. We can apply this equation. Okay, v is equal to u plus at. So we can apply this equation. Omega final is equal to omega initial plus angular acceleration in and time t. Omega final is 0. Initial omega is 5 pi by 3 plus alpha, and time is 60 seconds. So from here we can find the value of alpha. So we can get alpha is equal to minus of 5 pi by 3, okay, and divided by 60. Okay, you will get this 60 alpha, na? 60 alpha is equal to minus 5 by 3. You will get alpha is equal to minus 5 pi divided by 3 and multiplied by 1 by 60. So you can just cancel it out. It will be 12. So alpha will be minus pi divided by 36. Pi divided by 36 radian per second square. Now you have alpha. Now you can find the torque. Torque is equal to I into alpha. Torque for net torque on the body is equal to moment of inertia multiplied by alpha. So this wheel is rotating about this axis. Okay, this wheel is rotating about this axis. So you can find moment of inertia about this axis is given. That is, I think 2 is given. So you can write torque is equal to moment of inertia 2. Alpha is equal to minus pi by 36. Okay, and it will become minus 5 divided by 80. This torque is coming out to be negative. Why? Because this is a stopping torque. Okay, if this wheel is rotating in this direction, then you have to apply the torque if this wheel is rotating in a clockwise direction. And to stop that wheel, you have to apply the torque in anti-clockwise direction. That is why this torque is negative. Okay. So you can write in this way also, it is fine. Understood, Divyangi and Hiba? I mean, how to solve these kinds of questions?
Yes, sir.
Okay. Please write down. Scroll down.
Yes, sir.
So when you are applying a torque is equal to I alpha, tau is equal to I alpha when you are applying. So just keep in mind about which axis you are applying. You have to take the torque about the same axis. eh? and take the moment of inertia about the same axis and the angular acceleration about the same axis. So basically, na, you can say this negative sign of the torque is representing the resisting torque, or you can say opposing torque, resisting torque, okay, resisting torque, resisting torque, okay, resisting torque. Should we go to the next question?
Yes, sir.
Okay. So next question. In next question, we will use the theorem of parallel axis theorem. Theorem of parallel axis theorem we will use. Okay. So this is the question. So there is a square lamina. I told you lamina means two-dimensional object. This is a square, and this square have the side of 5 centimeter. Means this side, all the side will be of 5 centimeter, mass of 120 gram. Angular acceleration about this axis means about this axis, this square lamina is rotating. Angular acceleration is given about this axis. Torque you have to find about this axis. So for finding the torque about this axis, you should know the moment of inertia about this axis, and you should know alpha is given. So no problem for alpha. Alpha is given about this axis, but moment of inertia about this axis, you should know. Okay. So see how can we calculate the moment of inertia about this axis. If this is a square lamina, and where will be the center of mass of this? Center of mass will be in between. Geometrical center of the square will be the center of mass. Okay. So if there is an axis passing through the center of mass like this, and remember this axis and both these axes are parallel. Both these axes are parallel. This is the center of mass. This is the center of mass. Can anyone tell me this distance? The distance between the perpendicular distance between the center of mass and this axis? Shivyangi, can you tell me this distance? This whole distance is 5 centimeter.
2.5 centimeter.
Yeah, 2.5 centimeter. So it will be 2.5 centimeter distance. Okay. Now one axis we can take that is passing from here and parallel to the another axis. And this is the axis, we say axis of center of mass. An axis which is passing to the center of mass. CM is the center of mass. And this is the another axis. And from this axis, it means you can say the perpendicular distance between the two axes is 2.5 centimeter. So we want to find the moment of inertia about this axis. And moment of inertia about this axis we already know. MA square by 12. Okay, MA square by 12. You can see here. Moment of inertia table. Here you can see about this axis, if this distance is b, so what is the moment of inertia? Mb square by 12. If this distance is l, if you will convert this in the form of the square, then the moment of inertia will be ma square by 12. If you will take the side of this square as a, so the moment of inertia will be ma square by 12 about that axis. So moment of inertia about this axis of this square will be ma square by 12. So moment of inertia of this square lamina about an axis passing to the center of mass is equal to MA square by 12, MA square by 12, okay, and this distance is 2.5. So I am just writing it as A by 2. I'm just writing it as A by 2 because this distance will be A by 2 distance, okay. So you can write now this axis. If you want to find the moment of inertia about this axis, so you will apply the parallel axis theorem. Parallel axis theorem. So condition of applying the parallel axis theorem, two axes must be perpendicular and one of the axes must pass from the center of mass. So this axis is passing from the center of mass and both the axes are perpendicular. So you can write the moment of inertia about this axis is equal to the moment of inertia about this axis plus this plus mass of this square lamina multiplied by this distance. So you can write moment of inertia I about the another axis is equal to the moment of inertia about the center of mass axis plus mass of the square lamina multiplied by A by 2 square. It means this distance square you will take. So about this axis, the moment of inertia is m A square by 12 plus it will become m A square by 4. You can take the LCM. 12 is the LCM. So it will become ma square plus 3ma square. So it will become 314, 4ma square and 4 3s are 12. It will become ma square divided by 3. So the moment of inertia about this axis is ma square by 3. Now easily you can calculate torque. So torque is equal to the moment of inertia about the axis multiplied by the angular acceleration about that axis. Moment of inertia is ma square by 3 multiplied by alpha is given as 2. Okay, so you can multiply it with 2 and now you can put all the values. Mass is 120 gram. In 1 gram there are sorry, in 1 kilogram there are 1000 gram and we will use kilogram because kilogram is a SI unit of mass. So if mass is given as 120 gram, so we will convert this mass into kilogram. 120 divided by 1000. Okay, 120 divided by 1000. So 120 divided by 1000 you will write, and a square, what is a here? A is 5 centimeter. So you will convert this in meter. So a is 5 centimeter. So you will convert this a into meter. So you will divide this 5 with 100. So it will be 5 by 100 square, and here is 1 by 3 also, and here is 2 also. And I think you can do the calculation and your answer will be in Newton meter. Unit of torque is Newton meter. Okay, so here we have applied the uh, theorem of parallel axis theorem to find the moment of inertia about this axis. If we will get the moment of inertia about this axis, then we can easily find the torque about this axis. Means about this axis the body is rotating. Okay, okay, so please write down and you can do the calculation by yourself. Scroll down. Done. Completed, Hiba. Done, sir. So this is a rod, and this rod is pivoted from here. Means about this axis, this rod can rotate if you will apply the force. Okay. So they are asking find angular acceleration of the rod immediately after it is released. So now this rod is in this condition. Suppose this is a rod, suppose, and pivoted. This rod is pivoted from this point. Okay, and this due to the weight, this rod will go, or this rod will rotate in like this. Due to the weight will act it in downward direction. Due to the weight, this rod will move like this. Okay, like this. Okay, so suppose someone is means you are applying a force here, and someone means suppose you have released this rod like this, so this rod will go like this. So they are asking immediately after the release, what is the angular acceleration of the rod? What is the angular acceleration of the rod immediately after it is released? So first we will see what are the forces on this rod. This rod has the length of L. This rod has the length of L, and this is the axis of rotation, and somewhere here will be the center of mass, means at a distance of L by 2. So from here there is a force mg. Weight of the rod will be acted like this, and this is the center of mass, and this is the axis, and this distance is L by 2. This distance is L by 2. And what will be the moment of inertia about this axis? About this axis, the moment of inertia will be m L square divided by 3. Okay. Now you can find the torque about this axis. Torque about this axis will be force into perpendicular distance, means mg into L by 2. Mg into L by 2. And remember here, they are just asking immediately after it is released. Immediately after it is released means this rod, you can consider this rod as a straight. Okay. That is why I'm just calculating mg, means I'm calculating the torque like this. This force multiplied by this distance. Otherwise, after certain period of time, this rod will be somewhere else. Okay. So immediately after the release, so you can just consider this rod as a straight. So torque is mg multiplied by L by 2. Now this torque is given by moment of inertia multiplied by the angular acceleration. This is equal to mg L by 2. So the moment of inertia about this axis is ml square by 3. ml square divided by 3 into alpha is equal to mgl divided by 2. Now m and m will be cancelled out. L is cancelled out with this one L here. So you will get the alpha. So alpha is equal to 3g by 2l. 3g by 2l. Okay, this is 3 multiplied by g. This is 2 multiplied by l. This will be in the denominator. So the angular acceleration of the rod immediately after the release will be 3g divided by 2l. In the second question, they are asking find the angular acceleration of the rod when the rod makes 37 degree with the horizontal. So second case, so this is a rod now. When this rod will be released, so after it is making an angle of 37 degree. Suppose this is the rod, and after releasing, this rod is here and this rod is making an angle of 37 degree. Now center of mass will be at from this axis will be at a distance of L by 2 again, and mg will be acted like this. Mg will be acted like this. Now you have to find this distance for calculating the torque. Torque about this axis due to this mg will be mg into this perpendicular distance. Okay, mg into this perpendicular distance. So this angle is this distance is L by 2. Okay, this is, suppose this is O and this is A. So OA distance is what? L by 2. Now you want to find this distance AB. So what will be AB? See this, you see this triangle OAB. So this is a triangle O, this is A and this is B. And it is given that this angle is 37 degree. So if this angle is 37 degree, so this angle will also be 37 degree, alternate angle, because this AB is parallel to this. Okay, so this angle will also be 37 degree. So we know that in a triangle, if the angle is 37 degree, so this is 3 and this is 4 and this is 5. Now we can find AB. AB is equal to 4. Okay, AB you will get 4 times of L. Okay. Another way, if this angle is 37 degree and this OA is L, this OA is L, so this distance will be, you can apply the trigonometry here. You can find cos of 37, cos of 37. So cos of 37 you will get AB divided by OA, means base divided by perpendicular. AB divided by OA. So you will get from here AB, that is OA. OA, this is not L, this is L by 2. Okay. So you will get L by 2 cos 37. So basically this distance AB you will get L by 2 cos 37. L by 2 cos 37. So now you can find the torque about this axis, mg into L by 2. Torque is equal to force mg multiplied by perpendicular distance from the axis of rotation multiplied by L by 2 cos 37. Now cos 37 you can find with the help of this triangle again. Okay, that I told you earlier. This angle is 90 degree, this angle is 37 degree, this is 3, this is 4, this is 5. When you will find cos of 37, so you will write perpendicular base divided by hypotenuse, means 4 divided by 5. So you will get torque is equal to mg multiplied by L by 2. Cos 37 is 4 by 5. Okay, cos 37 is 4 by 5. So torque you have. Now moment of inertia about this axis means this will be the center of mass, and this will be the center of mass, and about this axis if the rod is rotating about one end of the rod is rotating, the moment of inertia will be ml square by 3. So this torque can be written as moment of inertia about the axis multiplied by alpha. Okay, and this alpha we want to find, and here we will have mg, we will have 4 mgl, 4 mgl, 4 mgl divided by 10. So moment of inertia is equal to ml square by 3 into alpha is equal to 4 mg into L divided by 10. Okay, so from here m and m will be cancelled out. One L is cancelled out with one L. You can find alpha from here. You will get 4 3s are 12 g divided by 10 into L. Okay, 10 into L. So finally you will cancel 12 and 10 with 2. So you will get alpha is equal to 6g divided by 5L. 6g divided by 5L. So in this way, we can calculate the angular acceleration for the second case. Means when the rod is making an angle of 37 degree. So when the rod is making an angle of 37 degree, so weight will be always acted in downward direction. So for calculating the torque about this axis, we will use force into perpendicular distance, and that force into perpendicular distance is equal to torque about this axis, and torque about this axis is equal to moment of inertia about this axis and alpha. Okay, write down. Okay. So after releasing now, when the rod will make an angle of 37 degrees, suppose rod will be here, then we are calculating the torque about this axis. Okay, so Dipyangi and Hiba, now time is over. You can take the screenshots, or you can just write this answer in the next class. Okay, time is over now. Okay.